Hello everyone, can you hear me? Right, so I'm just checking my audio right now. Right, thank you everyone for joining my first Twitch feed. Sorry for keeping everyone in the dark for so long. I've just been stuck coding and I kept thinking that every day would be the day when I would reach that milestone, and finally today is it. The Hope token is feature complete. The only thing that's left is deploying the contract onto a public testnet and just dealing with exceptions. So people trying to do things on the contract that are of rare occurrence and finding out whether the contract still behaves as intended. Right now, the contract is deployed on a private testnet, and so to interact with the contract I use the command line, but soon enough we will be interacting with the contract on my Ether wallet. So instead of thinking like Truffle's the command line, think of it like as right now it's what we use instead of my Ether wallet. So if I were to go and deploy this contract, I would just deploy it now onto the private testnet. I'd be using Geth as a deployment tool later on when we're up to deployment, and we'd use the Rinkeby network for testing. But right now, for demo, just going to be the test RPC, the private testnet. So I'm just waiting for it to deploy the code. And yep, that's deployed, and I'll just go to the command line where I can interact with the wallet. Same thing as my Ether wallet, that's a GUI, but I do the same thing. So the contract is deployed right now. And secondly, I need to run the backend, the other backend, which supports this contract. So I just need to make sure that I don't have a database here yet. Sorry, my mistake. I think I may have deployed the contract while that application was running. Sorry, I need to deploy the contract again. It's taking a while. I have to spend hours doing lots of test cases before sharing this with you. Just need to make sure that it's going to behave as intended under different conditions. Now I'll just go back to the console. Then after I'm in the console, I need to grab the address of the deployed contract. Otherwise, I won't be able to run the automation. It just wouldn't know which contract to do the automation on. the automation is required to synchronize between the two blockchains. So now I get the address. You won't need to worry about this as the end user, it's just as a developer that I would need to do this. Contract is deployed, and I've set in the config the address of that contract. Now I run the automation. So it's allowed itself to mint. Let me just expand that. It's downloaded the transactions from the Diamond blockchain. It has now seeded it without initial contributions. Now, what does this look like? What data is being generated? Just going to refresh. So I've linked this to Excel at the moment. This probably hasn't generated all the data yet. That's why I'm getting an error. Right, so it's generated these transactions initially. 10,000 Hope tokens. That's the initial amount. So our balance is 10,000. At the next block, which is block 705 in the Ethereum blockchain, it's distributed that 10,000 into all the different accounts, and these accounts would be how much we contributed, and that would be saved on the spreadsheet. I think that's maintained somewhere. I'm not sure if I've got the most up-to-date spreadsheet, but conceptually that's how it works. We've got the initial contributions. Now, where is it up to? It's still rebuilding the transactions. So whatever transactions on the Diamond blockchain, it's reflecting that in the Hope Diamond. If you look at the Diamond transactions, that's all the transactions that's happened. So you've got the 10,000 initial seed, which is how much diamonds we hold in our masternode, and it's minting like a couple of times every day. The balance is now around 10,400. And so we need to do the same thing in the Hope Diamond blockchain, and it's now at 10,105. It's still working through and doing the mints and then distributing it. And the mints are being batched up. So I can define when it does the batching and when it doesn't. And I have a thing called DMD intervals, and it's going to do a batch. The reason why the 18386 one, the reason why you see there's a 58.05 is because that is being batched up separately. So we've, on the Hope Diamond blockchain, we've minted 58 tokens. And why do you see 58? Well, 58, the sum of all these, which is from block 18584 to 23259. And the reason why is because we specified in the interval that we want to mint everything between 18584 to up to 23742. So everything in between these two block numbers, that will be one mint on the Hope Diamond blockchain. And we can specify how we want to batch it up. So batching is useful in case there's certain events we want to show individually on the blockchain, and we don't want one big amount hiding all the different transactions. So that might, like if there are special events like burning of tokens, we want, and we know that it should be treated differently, then we can enter the block number, and the next time we run the application, it's going to, it won't batch it up all in one go. But right now, everything after this block will be one amount that's minted on the Hope Diamond blockchain, as you can see here. So how this works, so that you're looking at the Hope Diamond transactions here. So this 10,000 initial seed, there's a transfer to all these different accounts, and then you've done a mint, and that mint gets transferred into all the different accounts again. Same thing here. Oh, and this one is slightly different. It's an unmint because I believe there was a token burn at one stage. So right now, this one, it does a batch transfer from the other accounts into the contract owner's account. Otherwise, it won't have enough funds to do the unmint. So this just happens in reverse. It does a transfer first to fund the contract owner's account, and then it does an unmint, which is effectively a burn of the entire total supply. Because that five token here, that happens because we've got the -5, as in the 5 tokens reduced in the Diamond blockchain. So this one in the Diamond blockchain, that is, okay, so I'm doing the transactions here. So I'm finding the -5 somewhere. Right, there's just too many transactions. So this -5, actually a better way is we've got a report that shows us how the two blockchains are synchronized with each other. And there's a reconciliation that takes place at every interval. Because both blockchains, they need to have the same amount. So if you look at the reconciliation report, you've got the Diamond blockchain on the left column and the Hope Diamond blockchain on the right column. So the total supply, they both agree, but how did we agree them? How did we go to this stage to have the Hope Diamond blockchain completely synchronized with the Diamond blockchain? Well, the reconciliation report gives us that information. 10,000, and this is how that $10,000 is matched. So on the Diamond blockchain, you just see the $10,000. On the Hope Diamond blockchain, that $10,000 is here, it's matched with this, and it gets distributed. So the total effect on the supply, total supply doesn't change, but it changes between accounts. Same thing with the mint. So these are all the what do you call it? It's not mints on the Diamond blockchain. They call staking rewards, right? Staking rewards here add up to 58.05. And remember what we did on the Hope Diamond? It's bashed them all up. 58.5. It's minted that. Here's the staking reward, and here's the mint on the Hope Diamond blockchain. And here's the distribution. The distribution of 58 tokens transferred. So all those accounts that hold a balance in Hope has received a portion of the mint. So that's how it works at the moment. Now, what if we want to change the behavior of the -5, as in the token burn? Instead of an unmint, we don't want to do a transfer. We don't want to reduce everyone's account balances. We just want to reduce the account that did the token burn. So we can change the behavior, but I won't show you this, but you can change the behavior so this becomes a burn and this transfer will not exist. So the only account whose balance will be decreased is the account that requested the burn. So let's just review the balances. Here are the account balances. $10,000, sorry, the 10,000 tokens, that goes to the contract owner's account. That gets distributed, so the balance is 0. All the other people's accounts, they receive the tokens. So let's just pick an example. When did a mint occur? The last mint occurred at, well, 713 is the last block, and how is that changing our balances? Remember, block 705. Block 705. That's the initial contribution stage. We remember that we as private investors, we all contributed amounts to the masternode. And we did that right now in our private testnet, we've put that up to block 705. And these are our contributions. I guess that was the biggest contribution, 26.7%. That would be the founder of this project. And then we've got some people around 12%. So that's all the percentages when we did our initial contributions. That's what percentage we are entitled to when the mint gets distributed from the staking reward. And remember, there was minting along the way. There was even an unmint. Notice how the percentage reverts back to the original percentage. Where we're now, 712, there was a mint. 712, a mint of 295 tokens. And then that mint was transferred to all the different accounts. So now, 712, we did the mint, remember? That is why the contract owner's account increased from 0% to 2.84% allocation. 2.84% allocation. So that's when the mint occurs. And it needs to distribute that based on what proportion balance people hold. So now the contract owner's account is back to 0% and everyone else's percentages are back to the original. So that's how it works. Now what happens if we start interacting with the contract? What will I do? Let's say I'll need to mint something here. Let's say I'm going to mint 100 tokens. Now I need to transfer something. I wonder if there's any new staking rewards. If there are any new stakes, it should be reflected here. No, I'm not going to wait for that. I think to simulate a mint or a staking reward, I'd do an unmint because it would need to synchronize back to the Diamond blockchain. So the balance is currently here. I'm going to reduce. Or maybe I can increase the balance. Yeah, I need to increase this by 100. So instead of going into my Ether wallet, because I'm still in the lab right now, I'm using Truffle. So yeah, using the command line rather than a wallet, but same thing. Let's say, what's the command for mint? I'm going to mint 100 coins. Now, what's my automation doing? It should detect that change. It would get that event and, right, it would unmint. right? So let's just refresh. Let's just refresh the report. So I've minted 100 coins. It's distributed that. No, it hasn't distributed because I did a manual mint. So the only thing that gets distributed at the moment is automated mints. So mints on the Diamond blockchain. So this mint, I just manually did that, so it doesn't get distributed. What happens at the next step, however, it unmints that. So whatever I try and do to the contract, it's always going to synchronize back to the underlying asset, which is the Diamond blockchain. Because remember, what's the balance of the Diamond blockchain? Whoops. The balance is 10,400. And what balance should the Hope Diamond blockchain what should that be? That should also be 10,400. And what the automation does, it makes sure that both blockchains have the same value. So if I try and force a mint on the Hope Diamond blockchain, if I just want to create 100 tokens out of thin air, the automation will prevent me from doing that. It's going to undo the mint that I've done. So if right now we're looking at the reconciliation report, we can see that it's unminted that amount. Or another way of looking at it, I'm simulating transaction, because we aren't doing any staking rewards. Well, none are happening during this video. I wanted to simulate the effect of a staking reward. So in this case, we've got a negative stake of 100. I know that doesn't really happen, but I just wanted to test the behavior. So assuming that our balance was somehow overstated by 100 tokens, it's now done a negative mint. And yeah, sure enough, whenever it does an automated mint to agree with the Diamond blockchain, it's going to do a distribution. So that's the intended behavior. I can also do a transfer, and that will also synchronize. Let's do a transfer. Let's transfer to some unknown account. Transfer $50. What's the command for? No. Transfer to another account. Let's transfer 12 tokens. I'll just wait to pick up that transfer. It's reconciled so it's picked it up and reconciled the transactions. I should see that reflected in the report as well. I know this is done in Excel. Eventually we could build the reporting so it could be built into our web application, but right now I just wanted to build out other features first before making everything shiny. Right now there is a transfer into a new account. Let's say this guy, he's got the new tokens and he's going to do a burn. He's going to burn right, why is that 24? I may have done the math incorrectly. Whoops. Did I do the in? I wonder why that's 25. I have to look into that later. Anyway, this guy, he burns. Let's say he burns 5 tokens. Whenever that picks it up, yeah, downloaded 1 transaction and it's done the reconciliation. Or maybe not, I don't see a reconciliation anywhere. So that's the burn. It hasn't reconciled the burn. And why not? So if it does the burn, we expect it to reduce the actual diamonds. So if you request a burn, it should send real diamonds into your wallet. So right here, if you are using my Ether wallet, you would be able to specify a diamond wallet address to send the tokens to. So what happens is, Hope diamonds, the balance gets reduced. So you will lose 5 Hope diamonds, and in return, you will get 5 real diamonds. So the reason why it hasn't done that, the reason why the diamond blockchain is still the same is because this is on a test. This is on a test environment. I don't have access to the Masternode wallet, of course. It's like duh. But I can look at the status of the burn. I am in MongoDB right now, just looking at the transactions in the database, our own database. We keep a record. We keep an internal copy of the blockchain. So right now there was a burn of 5 Hope diamonds. There's no change in the real diamond blockchain. What happens is there was a burn requested. So we also have a table. We keep a record of all the burns that have taken place, and it's telling me, right, at this time there was a burn requested. It was requested from this account, from this Ethereum address. However, we got an error. Connection refused. So yes, it tried to send, it tried to connect to a Diamond wallet and send the tokens over to that address, but at the moment I don't have a wallet running, but I guess you get the idea. When it's able to connect to a wallet, then you will get your real diamonds. So that's the next stage, is do the deployment. So that's how That's how it works from an end user's perspective. Instead of using the truffle command line that I have here, you would use my Ether wallet. So that would be the next stage. And the reporting right now is in Excel. Eventually, maybe we can build some charts and reporting where you can access just logging into a website. These are just telling me, okay, how has the balance changed from the original? Now what next? Yeah, maybe we also need better security for this, try and find ways to break this contract. But yeah, that's the next stage. When everyone starts testing it and breaking it, I'll come up with ways to make the contract more robust. If you want to take a look at the code, I know that not everyone's interested in code, but if you ever want to take a look at the code, you start from the highest level abstraction, which is app.js. That's the entry point to the application. And this is what it first does. It checks that the version of the contract is the same as the version of this application, the automation. Allows itself to mint, does the seeding, which is like putting in the initial contribution and that to allocate the 10,000 tokens. And at every interval, that could be every 15 seconds, for example, at every interval, it's going to do a synchronize, right? And what happens when you do a synchronize? When you do a synchronize, this is what happens. So this is still very high level. There's a lot of logic that goes into each function, but to describe each function, it gets everything that has not been reconciled. So everything, all the new transactions that's not in here. So this is what's been reconciled. And if there are new transactions coming in on either blockchain, it's going to try and do something to it. Like, let's say there was a staking reward. It's going to, well, firstly, it sees if there are any burn requests. So if there are any burn requests from the Hope Diamond blockchain, then it tries to settle it by going to the Diamond wallet and sending real diamonds to whoever did the burn request. So that's settling the burns. So that's what this function does. And how does it know who requested the burn? By looking at all the new transactions. And then after it's done the burning, it'll get all the new transactions again, get all the new transactions from the Hope Diamond blockchain, and then compares the difference between the two blockchains, so both Diamond and Hope Diamond, and determines whether an update is required. An update is required if the total amount do not agree. Well, excluding the burn that failed. So if update is required, then it'll do a mint or a burn or an unmint or whatever we can program in. So that's what the update thing does. We can program in different conditions, like whether we want to mint or a burn based on the block number. We can manually override the behavior. And then after it's done that, it's going to reconcile it again. So that's, if you're looking at the code, that's where you should begin. So this is what we've done so far. We've done all the features. There is a few rough edges we need to round off. And I think during this demo, there was possibly one bug. I'm not sure if it's me as the user doing the math incorrectly, or if it's something in the automation that I need to fix, because I think I've done a transfer twice. This should be 12 instead of 24. But after I fix that, the next stage is to deploy this on the public testnet for all of you guys to play around with. And then I also need to do my own automated tests as well. Maybe I could create a fake diamond wallet and a fake diamond blockchain, and that way I can run tests automatically with different scenarios rather than the time-consuming process of testing it manually. Might also be able to test different situations without having a real diamond wallet. So yeah, that's what we've been doing. And what next? Yep, just the deployment, Dockerizing everything, testing it, trying to hack into this, break it, and when we go public, it's battle tested, and we can use this as a template for many other assets. It can be another blockchain, or it might be someone's portfolio. Maybe could be any asset you can apply this to. Could basically start an investment fund. So yeah, thanks for watching. I hope this has given you some idea of how this token works and where it's headed in terms of future direction. So that concludes my video.